guys, welcome to another session on complex analysis, and today we'll be doing root of complex numbers. This is the fourth series of the complex numbers in complex analysis. Okay, so without wasting time, guys, let us just write down the most important information that we need to know for the root. Guys, thank you for coming this far with the video series, and we hope that you're going to enjoy this one as well. Okay, so the root of a complex number can be written or denoted as ck is equals to the nth root of r0, which is the modulus, e to the I theta 0 plus 2 k pi divided by n, where our k is equals to 0, 1, 2, n minus 1. Okay, so this is the general way to denote a root of a complex number. Now, the thing that you need to remember is that this theta 0 represents a principal argument of a complex number, and remember that a principal argument of a complex number is always between negative pi and pi. So if this theta 0 is not between that, let me write it here. Theta 0 should lie between pi and negative pi, but it should not be equals to negative pi, of course. Okay, so if it's not in this range, then we cannot take that as theta 0. Okay, now this is the general equation, guys. Okay, but for us to write the root of a complex number, the root of a complex number is going to be z0 to the n, which is just the nth root of r0, e to the I. It's just the same thing, guys. Okay, it's just we choose which one we want to use to denote or show our roots. Okay, 2 n minus 1. Let me just put this, okay, because usually, okay, it's fine, let me just leave it like that. So if you didn't go through the video of arguments, then please go through it such that you'll be able to understand why we have such rules that are expected from you. Okay, that's series number 3, which is the last series from this one. Okay, so let us go through this. Let us see some examples. The first example that we have here is find all values of the complex number minus 8i to the 1 over 3. Now, from what we see there is that our n is equals to 3. Do we all agree on that one? Why? Because we remember this from z0 to the 1 over n should be equals to the nth root of r0, which is the modulus e to the I, and have theta 0 plus 2 pi k divided by n. And then our k obviously will be equals to 0, 1, 2, n minus 1. So that information is very important. So our n minus 1 in this case is just equals to 2. So me, how I like to start doing this thing is I would start by writing this complex number that we have here as an exponential form, from rectangular form to exponential form. So the modulus of negative 8i is just equals to 8. You must know how to find the modulus, guys. Okay, we did videos based on how to find the modulus of a complex number, so I would expect you to know how to find the modulus of a complex number, especially for complex numbers like this one. So I hope you still remember how to find that. Now let us find the argument of this complex number. Sin theta is equals to negative 1. This implies that our theta will be equals to negative pi over 2. And if you look at the theta value, it lies between this theta value lies between negative pi and pi. Okay, now let us rewrite our complex number. Let us rewrite our complex number. Negative 8i as exponential form is just going to be equals to 8 and have this e to the I negative pi over a 2. Let me introduce, or let me put, because this is a principal argument. Okay, so we're going to have negative pi over 2 plus 2k pi, where our k is equals to 0, plus or minus 1, plus or minus 2, da 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 da. Now this is different from the roots of a complex number. This is different from the roots of a complex number. We'll see it just now. Okay, so let us rewrite this. Let us rewrite the general equation of the roots. Okay, now the general equation of the roots, as given previously here, I'm going to write it as the first one. Okay, so ck is equals to the nth root, which in this case is the third root of 8, which is r0, and have e to the I, and have negative pi over 2 plus 2k pi, and everything is divided by n, which is 3. And our k will move from 0, 1, 2. That's where it terminates. Okay. So this is just our complex number in exponential form. It doesn't mean this is the general equation of the root. Okay guys, so this is just our complex number. So the general equation of the root is given by this. Now if you can look at this, this can be rewritten as the general equation of a complex number is equals to 2ei of negative pi over 2 plus 2k pi divided by, oh wait a minute, this can be rewritten as, because the division I can already see it is minus pi over 6 plus 2k pi divided by 3, where our k is equals to 0, 1, 2. Okay. Now let us find our C0. Now our C0 means that if I'm looking for C0, it means that where is that other one? It means that my k is equals to 0, because the k here must correlate to this. Okay, so my C0 is when k is equals to 0. Now this is okay. Now this simply means that wherever we see k in the ck equation, we are going to substitute 0. So this will imply that we're going to have 2e to the I and have minus pi over 6, because this term will be equals to a 0. Now this can be expanded to 2, and let us have this as cos of negative pi over 6 plus I sine of negative pi over 6. Okay, so let me have it like this to respect it, guys. Okay, so our C0 will then be given by 2. Actually I can write this as cos of negative pi over 6. But this won't be really much affected, okay, because cos of negative theta is the same as cos of theta. So I can write this as cos of pi over 6 and have minus I sine of pi over 6. Okay, so I will expect you to understand what happened here because of the rules of trigonometry. Okay, now this will be equals to 2. This is a special angle, root of 3 over 2 minus I times 1 over 2. Okay, so this implies that C0 will be equals to, we multiply each and every term by 2, the root of 3 minus I. So this is one of the roots, C0. Okay, now I don't want us to waste any more time. Let us just go through and find C1. Okay, sorry about that, guys. My pen is running out of ink. Now let us find C1. C1 implies that K is equals to 1. Okay, so in the CK equation, we put K is equals to 1, becomes 2e to the I minus pi over 6. And if we put 1 there, it becomes 2 pi over 3. So 2 pi over 3, we can look at this as, okay, let me write it here. So I won't do this for every one of them, okay? I'm just giving you the idea of how to do this, or how I do it. So I have this 2 pi over 3. This can be seen as negative pi over 6 plus 4 pi over 6, which this is just 3 pi over 6, which is just pi over 2. Okay, so I can, yeah, you can just write that down. Now to continue, this can be rewritten as 2e to the I and pi over 2. Okay, so this can be 2 cos of pi over 2 plus I sine of pi over 2. Okay guys, so since these are special angles, I want to show you that a sine graph is given by this. This is the sine graph, and a cos graph is given by this. Okay, so these two graphs, this is what we have here. So cos of pi over 2 is equals to 0, and sine of pi over 2 is equals to 1. Okay, so this idea will always play an important role. Okay, so what we're going to have here is this 2 multiplied by 0 plus I, because this is just 1, so this is just 2I. So this is the second root that we need. Let us find the last one, because they said, oh, we said that our value of n is 3. So C2, this implies that our K is equals to 2 in the CK equation. Now, okay, let us just go through this one. What you're going to have is 2e to the I minus pi over 6, and have plus, now multiply that, is going to be 4 pi over 3. Okay, so using the idea that I showed you in the previous one, so this must be 7 pi over 6. Okay, 7 pi over 6. Now this can be later expanded to 2 and have cos of 7 pi over 6 plus I sine 7 pi over 6. Okay, you can use your calculators, but because this is a special angle and it lies in the on that quadrant, so it's going to be 2 negative root of 3 divided by 2 plus, no, it's going to be minus, actually it's going to be minus I 1 over 2. Okay, so this will be just negative root of 3 minus I, which is our last root that we have to find. So we had to find 3 roots, and we have got 3 roots, which is 1, 2, and the third one is this one. Okay, so we have solved this example. So guys, due to not keeping the videos to be long, I'll just cut it here and just end with example 1. We'll do example 2 and maybe example 3 in the next video segment of part 2 of lecture series number 4. Okay, for now, thank you very much. If you came this far, guys, please do hit the like button. Please do hit the subscribe button, as it helps with the growth of the channel. And let us just work. Thank you very much, guys.